Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
The thing that we want to talk about today is tornadoes. Also severe winds to some degree, but we're going to focus our time on tornadoes. They are fascinating. This is just one of those amazing, cool images. We've got a tornado with the lightning bolt at the same time. They are really one of the most fascinating things in all of weather phenomenon. Hey, let's introduce this with a tornado in Colorado. In May of 2008, one person died. Golf ball-sized hail. This is in a place called Windsor, Colorado. Windsor, Colorado is near Fort Collins. So if you look at a map of Colorado, the mountain front range starts here, right? We live in Woodland Park about right here, and Fort Collins is about right here, and Windsor was just kind of a suburb of that. And it's actually very rare for a tornado to occur in Colorado, at least in terms of a large damaging tornado. But this is one that happened really not that long ago. I'm recording this in 2010 right now. So let's watch some video footage of this Windsor tornado. You know, and the amazing thing about that tornado is it wasn't really that huge. We'll learn later about the scale. There's kind of a scale from 1 to 5, F1, we say to F5. And that was like 2.5. So they can be much worse than that. So, hey, what is a tornado, just as a side note? Well, it's a violent, dangerous, rotating column of air which is in contact with both the surface of the Earth and a cumulonimbus cloud. The wind speeds are between 40 and 110 miles per hour. Approximately 250 feet across, usually. They can get bigger, by the way. They travel a few miles before dissipating. So this is most tornadoes. The most extreme can attain wind speeds of more than 300 miles per hour, stretch more than a mile across, and stay on the ground for dozens of miles. Hey, there are several types of tornadoes as well. There's the cylindrical cloud tornado, which is actually kind of in the background image back here. There's a rope-like. This is kind of a rope-like one. See, it kind of looks like a rope, kind of twisting like that. And there's water spouts, and this isn't the full picture. A water spout, by the way, is kind of cool. It's a tornado over water. There's actually more water spouts that don't happen in severe weather. They tend to not be very intense, but the ones that happen in severe weather, as in supercell type deal, those are the bad ones. But if you're a boat out there in the middle of it, you got problems, but there are usually not a lot of people live on the water, so it's not usually as big a deal. Hey, how do we measure tornadoes? There's something called the Fujita Tornado Intensity Scale, named after Mr. Fujita, who taught at the University of, I think it's Chicago, somewhere in Chicago, and he was a famous tornado guy. An F0 is considered a weak tornado, and they basically categorize it by the estimated rotational wind speed. This just says wind speed, but it's because, of course, tornadoes, they travel in a rotating pattern. So the higher the wind speed, the stronger the tornado. F1, you can see you get a little higher wind speeds. This is in miles per hour. And when you get to the F5s, neighborhood 300 miles per hour, and that's devastating. It'll destroy everything. I mean, if anything comes into contact with it, it's done. Tornadoes are just, maybe some of you had experiences with tornadoes or friends or family. It's pretty devastating. We have my brother-in-law and sister-in-law. They own a farm in Iowa, and they basically lost their house to a tornado. They were lucky to survive. Tornado damage, you probably can know about this. Of course, it's the strong winds and the strong updrafts that do all the damage. Of course, then that knocks over trees, houses, cars, etc., etc. This is an amazing one here. This picture right here is from Greensburg High School in Kansas. And this was a E5. Actually, the E right there stands for the Enhanced Fujita Scale, or extended. There's a sort of the new version. This is the highest pulse rate. It struck the city in May of 2007, and you can see that was once a high school. Yeah, yeah, it's done. I don't know if there was like some kind of roof over the top, but a nice strong brick building, you think it could survive? It didn't, because it was an F5. And devastation can just be unbelievable. Hey, where do they strike? This is actually just the summary of, I think it's F3 to F5. So yeah, this is F3 to F5, so not F1s and 2. Most of the tornadoes that actually occur, though, are these weaker ones, but let's take a look at the really bad guys. The really bad ones tend to, you can kind of see kind of a pattern, throughout, like right there. That's where the bad ones, and occasionally you'll get them up in here. So, yeah, you can see some very devastating tornadoes. There's a thing, and actually worldwide, where you see tornadoes. These are just possibilities of places. You can see tornadoes. Basically, the United States is a big section. Europe, to some degree. Little parts here, right here. Actually, interesting thing, this is a little town, or not town, a little country called Bangladesh, and Bangladesh, sadly, has the most deaths of tornadoes. They have very high population density, and there's not a lot of warning systems. And even though actually the tornadoes are worse in terms of their intensity in the United States, it doesn't tend to happen there as much. The deaths, because we have a better warning system, etc. So, and you can see, of course, Australia, the Philippines get them, South Africa, and Argentina. All right. What time of year do they occur? All right. These regions over here, July, August, September, so kind of your, this is the range. April, May, June here for kind of the main Midwest section, and January, February, March for down in the Southeast. And it's, a tornado can happen any time of the year, but this is sort of the general time of year that you find them happening. You don't want to sketch some of these graphics. While we're at this, the thing they call Tornado Alley, where you have kind of the worst section of tornadoes. Colorado, where we live, of course, right here-ish, we're not in Tornado Alley, but we're getting kind of close to it. But you can see big tornadoes. We live in the mountains. In the mountains, it's very rare to see a tornado in the mountain. That said, and I've lived in Woodland Park for 2 years, and there's been 2 tornadoes. But before that, it was 10 years before that. It's very, very rare to see a tornado in the mountains. Mountains mess everything up. The changing elevation. You need a pretty flat place, and if you know your topography, this whole part of the United States is it's pretty flat. So, just to give you another data here, you don't need to copy this down. If you want to print it and put it in your notes, that'd be all right. What number of tornadoes per year? This is an average. So Colorado, you can see we've got about 22 every year. Texas gets 139 a year. Wow. Puerto Rico doesn't get any. Alaska doesn't get any. Hawaii gets 1 a year total, on average. You can kind of see, obviously, where do you see the big numbers? I'm seeing big numbers, like right in here. And this next graph actually is almost a better one. The average number of tornadoes per year per 10,000 square miles, because it's kind of like Texas has lots of space, so does it have as much tornadoes? Well, Oklahoma's kind of the winner here. 8.2. Actually, in Texas or Florida is bigger, 9.4. So I see a couple of big numbers there. So 6s and 5.8s. This is per a certain number of space. If I were to take this, square that big, I don't know how big 10,000 square miles is, but let's say that's what it is. That's how many you see in that particular area. And you can see kind of big numbers, kind of in these ranges here. And that kind of goes with that other map we saw earlier, all right? And everyone always wants to know, what were the bad ones, right? Okay, what were the bad tornadoes? You don't need to copy this down, but March 18th, 1925, they lost 695 people. They died. 2,027 injured. So this was a huge. Sometimes they form in these big cloud banks or these, in Missouri, Illinois, and Indiana. F5, very bad. May 6th, 1840, they lost 317 people. Probably the more recent ones. Most of them. See, these are pretty old. 1936, 216 people alive. Another 1936, 2 days in a row. Look at that. Do you see that? That must have been a bad couple of days. My word. One in Mississippi, the next day they hit Georgia. My. So you can kind of see the issue, of course, is we've gotten better and better at detecting them. Speaking of detecting them, how do we detect tornadoes? The beauty is we have this thing called Doppler radar, and we learned last time or time before about radar and how it works, and it's just getting better and better all the time. The key, though, is to predict where it might be likely. So what they want to do is to figure out where they actually occur. So let's actually look at a Doppler radar animation to show you what we can see now. Note on this one just the amazing in this animation. Look at how this is rotating. This cloud right here is going to kind of repeat itself. This is from June 5th of 2009. Look at just the amazing Doppler radar that they're picking up of this tornado. This was actually an F5 tornado, one of the biggest ones possible. So it's amazing how how vivid these images are. The radar is getting so. And this over here on this side is just a similar kind of a deal where we're seeing the rotation just with a different kind of a lens, I guess. So we can see those things, but the key thing is we want to see what types of clouds will have the likelihood that a tornado can happen. Because you can never exactly predict a tornado. You say, well, one is a likely out of this particular cloud. And then they said, they send off sirens and bells and say, get in safe places. Now, what actually causes a tornado? So this is the fascinating thing that I was learning as I was preparing this. All right, so first of all, it happens in a supercell thunderstorm. So you have to have a supercell thunderstorm, which we learned about earlier. Then you have these updrafts. They interact with horizontal winds. So let's think about this. You've got an updraft. It's a draft going up. Horizontal winds is winds going this way. So we have winds going in opposite directions, okay? And then you've also usually you get winds kind of going this way, and sometimes you get winds. When I say updrafts, it's usually not straight up because it's kind of at an angle. Because usually a storm is moving off in a particular direction because of the winds, and this can cause the wind to begin to rotate. And the rotating air, by the way, is called the mesocycle. I'll show some pictures in a minute. And then we get a counterclockwise. By the way, that's just in the northern hemisphere. The southern hemisphere, it's by the way, the counterclockwise viewed from above in the northern hemisphere, and it would be clockwise in the southern hemisphere viewed from above. Circulation that develops in a supercell. It may evolve into a thunderstorm. Okay, so let's take a look at this pictorially. So here we have the horizontal winds in red right here, right there. And then we have the updraft, and that causes this to begin to swirl, as you can see. And then it is this is like, picture one, time one. And then the second thing that's going to start happening is we start getting some motion this way. We can start seeing this swirling mass. This is this mesocycle, And then if it starts to continue to rotate, what actually happens is it starts to narrow. Usually it starts out really wide, and then it starts to narrow. And as it narrows, the speeds of the winds pick up, and boom, you can make the tornado down here, you see. So you can get this narrow band that starts to rotate, and then you get excitement. So the rotating cloud becomes narrower, like I said. The wind speed increases. Now, if you have a mesocycle, about 60% of the time, you're going to make a tornado. The other 40% doesn't make a tornado. All right. Here's kind of an interesting little thing. With the birth of a tornado, this is kind of the sort of a little like poem. Let's do a poem. Okay. Winds going up, winds going down, winds coming together, winds going round and round. Put them all together, and believe me, mister, you got a mean old twister. There you go. All right, so that's kind of how a tornado goes. Winds going up, as we talked about. Winds going down. Winds coming together. Winds going round and round. Put them all together, and believe me, mister, you get a mean old twister.